Okay, cool. I think we're good to go. So hi, I'm Andrew. I'm a software engineer at Facebook. Been working on the JS profiling API for the last few years now. Wow, time flies. And yeah, today I'm just going to be chatting a little bit about some updates for the API, where we're at shipping wise on like various UAs, and some ideas for extending the API with some additional context regarding like other non-JS execution and some of the challenges there. Along with my colleague, Corentin. So cool, I'll kick it off then. So just a quick recap of what the API is, since it's been a little while. Refresh is always good. So this is a web exposed sampling profiler for measuring client JavaScript execution. So think of the DevTools profiler in like Safari or Chrome or Gecko. Web exposed and accessible by script. So sites could measure their own like JavaScript execution through invoking a sampling profiler, collect traces, and either inspect them locally for analysis or send them off to a server for aggregate analysis. And the real edge here is this helps you provide like actual like RUM client characteristics on like real user like devices. So you end up like unbiasing yourself from skewed like high-end developer machines, as well as get insight on some niche configurations and performance characteristics of strange devices in the field. The API is now shipped in Chrome 94 and underwent a few changes recently as a result of feedback from other working groups, as well as GitHub issues that I'll go into pretty quickly. And there's a link to the repo just there. All right. So the API itself, fairly straightforward to use. We changed over to a synchronous constructor in order to provide better developer ergonomics. So one pattern that we're often seeing, especially in the origin trial that we ran in Chrome, is that a lot of the logic that you wanted to profile couldn't wait for asynchronicity in many cases. And not only that, but the way the spec defines sampling in the first place, it wasn't quite necessary in order to enforce in a synchronous constructor. So we got good feedback on that and switched over to a synchronous constructor, which, while it doesn't block for the first sample, ensures that it is kicked off by the time it returns. And so the two parameters that you provide to your constructor here are the requested sampling interval in milliseconds, as well as the max buffer size, another extension that we talked about in the working group, I believe last TPAC. And so that's designed to ensure that the developer does not go overboard and collect more samples than they could possibly imagine processing. Think similar to the performance timeline, resource timing capacity. All right. And here's a very simple example of how you might go ahead and collect a trace for, say, like the DOM load event. So you kick off your profiler in the top level script. That's typically where, like, since the profiler only measures JavaScript right now, you're not really missing out on anything, since you can combine it with data from the resource timeline and other performance entries. Like event timing is a very popular companion to this API that we've been seeing. And it's particularly useful for debugging like input latency. And so yeah, up here is just a quick example of how we can collect some data along with the trace, send it over. It shares a time origin with the profiler samples, so you can easily cross-correlate them and present them in like a unified tracing view. Cool. And one other addition that is not on these slides is that document policy was leveraged instead of feature policy, which we discussed in the working group prior, to provide per document warm-up semantics. So when a page wants to profile, in order to avoid incurring the hit of building additional metadata in order to unwind stacks, serving down the appropriate document policy at the time of page load will ensure that the document can begin profiling very quickly, and we don't incur any overhead on pages that don't wish to profile. Sweet. All right. And here's a quick overview of the tracing format. Basically, it's very similar to the V8 and SpiderMonkey tracing formats for JavaScript, in which it uses a trie representation because common stack ancestors tend to be a pretty frequent pattern in traces. So you have your stack frames, resources, samples, and stacks. The frames themselves refer to are one-to-one with ECMA functions, and they refer to items in the resources array for providing script URLs, since those are also something that is duplicated quite often. The samples themselves contain references to stacks, as well as the timestamp which the samples were taken. And the stacks array provide linkage between frames and reference each other as well as items in the frames array. Cool. So yeah, I mentioned before that we shipped in Chrome 94. So what's going well so far? We have a few weeks of data now as to how we at Facebook have been using the API, as well as other large vendors. So the initial data is actually quite a bit better than we anticipated regarding top-level metrics. Enabling the profiler for a subset of users that's uniform slowed our load time by less than 1%, which is pretty great evidence for the fact that we can leverage this approach with fairly minimal overhead moving forward. One of the other benefits that we didn't see before is that it provides a very drop-in solution for perf analysis. It's very easy to onboard teams to this approach because it's agnostic of any underlying frameworks or tooling. You can just integrate a script or module that handles all the profiling, and you're good to go. So there's a lot of potential here from a third-party RUM point of view as well. And we've seen very strong adoption from other industry partners, such as Microsoft, who have actually started participating in some of the specification discussions as well, which is really awesome. But yeah, with every good thing comes some bad. So what could be better so far? And one of the main things that we've been observing is that non-JS execution is fairly hard to identify in traces. This was something that we talked about back at TPAC 2018, actually. When we were discussing different categories for the profiler. But in practice, what we're seeing is that top-level user agent work, such as scheduled paints, layouts, garbage collections, are fairly hard to distinguish from idle execution. And we don't really have good signal without resorting to some of our older approaches, like spinning a RAF loop, for instance, whether or not there's work being performed or the browser is idle. Not to mention certain things like GC activity adds to the noise of our traces. We'll demonstrate, or we'll show that certain functions might take a more variable amount of time than they would otherwise if they trigger a GC. And yeah, as I said before, it's any asynchronous rendering work is not measurable and it's very hard to track, unlike the rest of client script. So I'm going to pass it off to Corentin, who's been working on a explainer for extending the profiles with a state attribute that hopefully aims to provide more insight into what's happening in the non-JS time.
All right. Hey, Corentin here. So yeah, to solve the issues highlighted by Andrew, we're proposing to update the specification to add a way to tag the sample captured by the profiler. So if you, next slide, Andrew, please. So, so the idea is to highlight a category of work performed by the user agent at the time the sample was captured. So really here, the goal is to bring us closer to the profilers that are available today in DevTool, where you can see how the events are categorized in types such as scripting, rendering, or GC activity. And so, yeah, so this brings us to what should be the marker candidates. So next slide. And here, yeah, the main issue here is interoperability. We want a marker to have the same meaning across tracing and user agent. And it's not as easy as it sounds, and we're very interested in feedback in this area. So we have a couple of candidates in mind. Of course, the scripting tag is an easy one. So we could argue that this one could actually be optional, meaning having no tags and a stack implies scripting activity as it does today. We could envision a GC tag to represent a post due to a garbage collection task. Or we could also imagine a parser tag to a parser tag to show our parsing activity, but then the question is, should it include the HTML parsing or just be limited to JavaScript parsing? Or should we even expose this marker? On the rendering side, here it's a bit more difficult to spec. The event loop processing model only gives us a way to spec the entire rendering pipeline. So we could imagine a tag aggregating style, layout, and paint in a single marker. However, it would also be very useful to be able to split those markers. And there are work in progress efforts to add those steps in the event loop processing model. On the next slide, we can see the modification we propose to the IDL. So we suggest adding an optional string to the profiler sample IDL that we return from the API. And for an example of a trace, next slide. Yeah, so here we highlight, it's just an example of, for example, noise that is added through a GC event, where on the left side, you see the trace that is returned by the API today, where you have a longer trace that you would expect. And on the right side, you are able to immediately mark this sample as having been impacted by garbage collection. And same goes for example, synchronous reflow, or simply layout or rendering activity outside scripting event. And so there are security and privacy concerns for this API. And so first, we should not expose work performed on a cross-origin document, meaning that the top level user agent work may only appear in a trace if the responsible document has the same origin as the profiler. On the marker side, we have to be very careful not to introduce a new side channel. And it's worth considering if you should require cross-origin isolation to surface markers, for example, such as the garbage collection event. And so on the, as mentioned during the presentation, we have a couple of open questions where we are looking for feedback. And so we are interested to know if there is interest in, breaking down the paint marker into style, layout, and the actual paint itself. And yeah, should we require cross-origin isolation to surface data such as GC event, which can be very sensitive? And finally, should we even surface this information through the GS self-profiling API? There are a couple other candidates which might be better places, such as the performance stemline API. If you want to continue the discussion, we have opened a pull request with that explainer where we go into more details and specifics.
Cool. The rest is just appendix, so that concludes the presentation part.
Okay.